So guys, welcome to Soldiers to Academy once again. Very embody our motto from confusion to clarity and from test to testimony. Today we are going to be talking about what? Organic chemistry. So what is organic chemistry? Back in those days, we define organic chemistry as the chemistry of life, that is the chemistry of plant and animal, of the chemistry of living things. But as time goes on, as experience goes on, so we later we define organic chemistry from the chemistry of living organisms to chemistry of carbon in relation to other compound in which the experiment was carried out by what Fedicola. More of it will be talked about in the next video about the what in the what of the in the history of what organic chemistry. Today we are going to move to the main aspect. But before we understand what is organic chemistry, what organic chemistry is all about, you have to know the type what you call what hydrocarbon. Hydrocarbon. So hydrocarbon. For hydrocarbon, hydrocarbon can be defined as the what the compound involving hydrogen and carbon. This is a very essential thing you need to know before we go deep into what organic chemistry. What are hydrocarbons? Compound containing of hydrogen and carbon. This is classified under two types. We have aliphatic hydrocarbon. We have aliphatic. Let me just use the acronym of HC. We have aliphatic hydrocarbon and we have aromatic hydrocarbon. These two, aliphatic hydrocarbon and aromatic hydrocarbon. So for aliphatic hydrocarbon, we divide aliphatic hydrocarbon as those compounds contain which are arranged in what? In a straight branched form. They don't contain of what? Benzene rings. But for aromatic hydrocarbon are mostly arrays. We are still going to get to the meaning of all that. Are mostly what? Arrays. So arrays will have at least one or more benzene type structure. So for this aliphatic hydrocarbon, we can further classify it into saturated and unsaturated hydrocarbon. Saturated and unsaturated hydrocarbon. But know that aromatic hydrocarbon are all unsaturated because they are full of what? Arenes. Arenes. Which are the what? The benzene type. They are also known as what? Benzene type structures. They are benzene type structure. So we have saturated and unsaturated hydrocarbon. Saturated hydrocarbon are what? The compound containing of ordinary single bond. A best example for this is what we call what? Alkane. The best example is what? Alkane. While for unsaturated hydrocarbon, compound containing of what? Two or triple bond. Are you getting me? So double or triple bond. The best example are alkene and alkyne respectively. Alkene and alkyne respectively. So for your alkane contain of what? Single bond. For your alkene contain of what? Double bond. For your alkyne contain of what? Triple bond. These are the what? The basic things you need to know about what? Hydrocarbon. Now let's move to the what? For the characteristics of this alkane, alkene, and alkyne. So guys, want to compare alkane, and alkyne. But I will add another one which we call what? Alkyl. These are derived from the word alkane family. I'm going to explain it. So when we are talking about the comparison of this comparison it was from what? Homologous series, which thought out about the what comparison between different compound. Now we have this has, as I said earlier, this has what a single bond. This one uses what double bond. This one uses what triple bond. For this is an example of this alkyl is attract what is extracted from alkane. So it's also of what single bond. I'm going to explain it. Before I start doing this, there are some prefixes you need to know about organic chemistry. We have what we call what met, het, pro, put, pent, ex, ept, opt, nonen, deck, and also on deck and duodec. You have to be familiar with these prefixes. Pent, sorry. So now, for met, whenever you are having met of something, it means one. In organic chemistry, et of something is two. Your prop is 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. These are the common prefixes you have to be using. It's very rare for you to see this on deck and duodec, so at least you have to master all this. So met means 1, et means 2, prop means 3. And another thing to know, it is only alkane family that start from met. Others like alkene and alkyne start from what? Et. This alkene, you know I told you earlier that it was extracted from alkane, so it also start from what? Met. But for this alkene and alkyne, they both start from what? Et and not met. So what does this mean? That is, assuming, how do we name a compound? So let's say we have, you can be any of something of methane, ethane, propane. What does those things mean? For you to name a particular compound, we uses their what? We uses these prefixes, which is indicating the number of carbon. Are you getting me? So if you have met of something like methane, are you getting me? Met of alkane, it means what? Met of alkane family. The met there is signifying that it is having just a single carbon. And in there is what? It is identifying that it is an alkane family. Assuming you see what? Methane. You can see something like methane. Methane. This met here is telling you that this particular compound is containing of what? Of a single carbon. Are you getting me? And the N right here at the back here is signifying that it is a what? Alkane family. It's showing you the family it belongs. Assuming you have something like what? Let's use pro. Assuming you have something, you see a compound like propene. This prop here is telling you that it contains what? 3 carbon. The in right here is identifying what? The family name. Are you getting me? Which is what? Alkane. Are you getting me? You see they all start from what? ALK, ALK, ALK. So that's the general name. So for this one, N in I, that is ending in that word will be changing what? That will determine the classification where they belong to. Assuming you have something like ketine, that is, this ketine will be telling you that what? This earth will be signifying that what? You know earth is 2. That is, this compound is containing of what? 2 carbon. And this iron right here will be telling you that it belongs to what? Alkyne family. It's as simple as that. Are you getting the point? So for a carbon, you have to know that a carbon, there's something we call what? Catenation. We say what? The ability of the what? Of the carbon to be able to attach with what? With 4 different compounds. So for a carbon to be stable, are you getting me? For a single carbon to be stable like that, you have to attach it with another 4 different what? Compounds. We mostly use what? Hydrogen, 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 hydrogen. This is an example of a particular hydrocarbon. If you want to name this kind of hydrocarbon like this, it's very, very simple. You just need to count from what? You just need to find how many carbon is right here? Just 1 carbon. Are you getting me? Just 1 carbon is here, abi? One carbon in organic chemistry, 1 means what? met. This type of bond is present in everything. You can see it's just single bond. Are you getting me? It contains of single bond. And another way to know, I told you that it's only alkane family that will stand for what? Met. Others will stand for what? Et. Are you getting me? So we just say met abi, then we see is that contain of what? Single bond. Single bond belongs to alkane. Then this alkane family is having a single carbon. From alkane is going to change to what? Methane. You get it? Assuming you have a compound like this, C12 H H H H H H. You know I told you that for a carbon to be polars, you have to attach with what? 4 compounds. How did I get all this? So we said this one C abi, this is the first, it attached to this one, attached to this 2, attached to this 3, attached to this other C 4. It is completed. This one too, 1 2 3, attached to this back 2 4. It is completed. If they ask you to name this kind of compound like this, you just say, okay, how many C, how many carbon? Carbon is very essential in it. So we have how many carbon, the particle, all these hydrogen no really matter right here. But by the time we start naming compound, you will know more about them. So how many carbon is here? 2. Are you getting me? You just go to your, what's 2? 8. So we have none, 8. Then the next thing you have to check is what? What type of bond is present? Is it single or double or triple? I can see this what? A single bond holding them together. A single bond is what? Alkane. Alkane containing of 2 compounds. They will have the what? Thing. Are you getting me? ANE will just be identified telling you that what it is and what? Alkane family. Assuming you having a compound in this one, C double bond C. It has this first carbon have already been attached with double. It will mean, you know, out of 4, it will mean how many? 2, abi? Let me attach with 2 more hydrogen. This second C2, this second carbon is also attached with 2 bonds. It will mean how many? Another 2 HH. Now, having it to be completed like this, how do you name it? You just say how many carbon is present also? 2 carbon. 8. Now, what bond is attaching these 2 together? Are you getting me? What bond is attaching it together? You can see is what? Double bond. What double bond? Alkene. Then it's going to be ending with what? E and E. Are you getting me? Unlike this one that is attached with one single bond, we said it's going to end with what? A N E. Since it's attaching with double bond, it's going to end with what? E N E. Assuming you're also having something like triple bond. So this first carbon is already attached with 3. It will mean how many? 1. You know I said the maximum is 4. This one too is what? 3, it will mean how many? 1. So now this kind of carbon, how do you name it? How many carbon is present? 2. And 2 is what? 8. From the table over there, your 8 is what? 2 carbon. The number of carbon is very essential. And which type of bond is present? 3 bond. 3 bond is what? Alkyne. Definitely the family is going to be ending with what? I. Y, N, E. As simple as that. Are you guys getting me? Now you might want to write the molecular formula. Are you getting me? These are structural formula and this is the name of the compound. The structural formula, the name. What about the molecular formula? That one is very simple. How many C do you see here? Just a single C. How many hydrogen are attached? 1, 2, 3, 4. CH4. So CH4 is what? Methane. So you guys should be hearing that CH4 methane, CH4 methane. This is how they name it. Are you getting me? How many C is there? 2C. How many H is there? 6. C2H6 is called what? Ethane. Are you getting me? Which other one? How many C is here? 2. How many H here is what? 4. C2H4 is called what? Ethane. And how many C is here? 2. How many H is here? 2. C2H2 is called what? Ethyne. These are the basics you need to do. Now let's now check the general formula. Each has their own general formula which you can easily use to what? In naming. Now let's go. So I hope you can get these basics. Now let's go. So now the next thing now is to do what? Is to write down the general formula and use it in getting each compound under each family.